Hello viewers. In this session, I am going to explain about the types of stresses and strain. In previous session, I have explained that what is a stress and a strain, how it can be measured for the different types of material. So here, before getting into this type, first you have to know that what are the different types of loads which are occur. So already you know that the stress is nothing but resistance offered by the material. That is a force ratio between force to the area. So here this is a material without applying any load. Here you can see that this is a tensile load. So whenever this material is subject to the tensile load, there will be the increase in length. Okay, and there will be the reduction in the lateral dimension. So here if I am taking that stress, it is nothing but tensile load to the area. So similarly, if I am applying the compressive load, there will be the reduction in the longitudinal dimension and there will be the increase in the lateral dimension. So where you can see that compressive strain, and here the stress is nothing but compressive stress. It is a ratio between compressive load to the area. And here you can see that this object is subjected to the tangential shear. This is nothing, it will create the tangential, that is a shear stress. And whenever anything is subjected to the torque, if we are applying the equal and opposite torque, that is a twisting load. So this behavior will be different. So before getting into this, you should understand what is a stress and strain. Stress is nothing but force by area, and strain is nothing but change in dimension to the original dimension. This will be, this is stress and strain types will be varied according to the application of different types of loads. So if you are taking that different types of loads are axial load, shear load and torsion. And how the material will behave, there may be the elastic behavior or there will be the plastic deformation. So here now I am going to explain that what is the different types of stresses and what is the Hooke's law and what are the different elastic constants and what are the relation between these elastic constants. So here the tensile load is nothing but the pulling opposite forces, and there is a elongation. And compression means this is the opposite pushing forces, that will be the causing of shortening of the material. And shear forces, it is a parallel tangential force, it will cause angular deformation to the structure. So if I am taking the normal stress, it acts perpendicular to the surfaces, and the shear stresses will be acting parallel to the surfaces. So the different elastic constants, before getting into this you should understand that what is a Hooke's law. So within elastic limit the stress is directly proportional to the strain. So here this E is the proportional constant, and here there are different limits are there, the proportional limit, elastic limit, and the Young's modulus is nothing but the ratio between stress and strain. So different the elastic constants are Young's modulus, shear modulus, bulk modulus and the Poisson ratio. These are all the four elastic constants. If I am taking that the relation, see the always we are representing the Young's modulus by E and the shear modulus by G, the bulk modulus by K, and the Poisson's ratio by the mu. So these are all the relation. If I am taking the relation between the Young's modulus and shear modulus, it is nothing but G equal to E divided by 2E into 1 plus mu. And if I am taking the bulk modulus and the Young's modulus, the relation will be K equal to E divided by 3 into 1 minus 2 mu. And if I am taking the relation between the bulk modulus and the rigidity modulus, the thing will be different. Okay. So next here you could understand that the thing in this video are what is the stress, and what is the Hooke's law, and what are the different elastic constant have it is related. So thank you for listening this video. Thank you.